An investor's well-diversified portfolio has $200,000 in cash. The investor aims to invest in short-term, one-year large-cap company bonds prior to using the cash to invest in an upcoming IPO. Currently, 2 large-cap company bonds on the market to purchase, both with one-year maturities. One of the bonds, Bond A, non-callable bond. Bond B is a callable bond. As a fixed income analyst, you are asked to conduct an analysis. For the 2 bonds offered by large cap companies, right, plural perhaps, which duration calculation would be the most appropriate to use to measure interest rate risk? Modified, Macaulay is not interest rate risk, really, it's a measure of time, so we can get rid of that. Modified or effective. We have one that is a callable bond. For that, we would want to use effective duration. For Bond B, as the benchmark yield curve declines, the slope of the tangent line to the bond flattens as the benchmark yield declines and reaches an inflection point, after which the effective convexity becomes, and remember we drew this out, it looks like this, right? It flattens the line to the curve, the tangent flattens before convexity becomes negative. All right, our narration at the top is basically the same. The following information on bonds A and B was obtained. A, effective duration, effective convexity, and B. Compare the interest rate risk of A and B. And what we're going to do, because we're not really told much, is we're going to increase yields 100 basis points and we're going to decrease 100 basis points, the change in the curve will be 100 basis points because we have the effective duration for both. So let's increase 100 basis points. It is the duration statistic multiplied by the change in the curve, adding the convexity. We have positive convexity on bond A, 1/2 times convexity statistic times the change in the curve squared, negative 7.33. However, the callable bond, the duration statistic times the changing curve plus 1/2. Notice we have a negative convexity statistic here. So we'll have a negative amount here. And since this is negative, we will be subtracting. Plus a negative is minus the amount, negative 8.8. So for an increase in rates, bond B drops by more. Let's look at a decrease in rates. Bond A will increase by 7.633%. Bond B will only increase by 5.69% because as rates are dropping, remember the straight bond does this, the callable bond gets pulled to its call price. So it will increase by more. So if you drop rates, bond A outperforms. If you raise rates, bond A outperforms. Compare the interest rate risk of both. Bond B is riskier than bond A. For the percentage price change for bond A, given a 200 basis point increase in benchmark yield, what part of the price change is of the most concern? When you have a straight bond, duration always is the bigger component. So duration. A colleague asks whether you also consider looking at key rate durations when comparing the interest rate risk of bond A and bond B. Would research into key rate durations for A and B help you make a better decision about interest rate risk of the 2 bonds? Well, they're one-year bonds. How many key rates are you going to have? Not only that, the sum of the key rates add up to effective duration anyway, so not really. The answer here is going to be no. The investor's portfolio is diversified, and the fixed income component of the portfolio has bonds of various maturities with a duration of 7.48621. What would happen to the effective duration of the fixed income component of the investor's portfolio if bond A is added? Remember, bond A had a duration of 7.48621. They're the same. Wouldn't matter. You wouldn't change a duration because you're adding something with the exact same duration. So it would stay the same. For the 2 bonds under consideration, would analytical duration estimates or empirical duration estimates be most appropriate in conducting your analysis? Large cap company bonds, so they're going to have some kind of credit spread. So there is a negative correlation between the spread and changes in curve. So the analytical duration would tend to overestimate the price change with an increase in the curve and underestimate the price change with a decrease in the curve. So analytical duration would probably be the better one. Empirical duration would be better, because this looks at what actually has happened versus what theoretically could happen. What impact would a flight to safety have on the analytical duration estimate of bond A? This is government bond yields falling and credit spreads widening. What impact would a flight to safety have on the analytical duration? So analytical duration is going to look at the change in the curve, right? It's not going to consider the change in the credit spread. Now, the CFAI wants to say no impact, but that is not entirely true. Let's draw out the relationship, and let's do a tangent line at this point in time, and let's drop rates considerably so that the rates drop to here, price increases to here, and draw your tangent line. Steeper tangent line, that means the bond's duration has increased, it has become more sensitive. So what impact would it have on the analytical duration? It would increase the duration, as opposed to saying no impact. I think what they were trying to get to was that, well, since it's just the changing curve that you're looking at, it would have, if you estimate it again with the same changing curve, it would have no impact. But if you did have a flight to safety, and you did look at the bond's duration at that point in time, it would increase.